Hello, I'm an old guy and I do maths. Today we're looking at linear simultaneous equations. And just so that you have a really clear idea of what we're looking at and looking for, we're looking for the coordinates of the point at which two linear graphs meet, their point of intersection, which will be a single pair of coordinates, x and y. And that's all there is to it, he says casually. There are several ways of figuring out what these points are. There's at least 4 or 5. What we're going to look at today, to start with, is a method called substitution, which I think is the simplest method. It's not one that's available every time, but it's a method that will work for a considerable percentage of the time. Sometimes you need to resort to a thing called elimination. Sometimes you can use matrices. There are other ways. Okay, so let's get into this. Right, there's a lot to take in here. Let's just get all of that into frame. So here we have two linear equations, y equals 2x plus 5 and y equals negative x plus 7. Now I've graphed these individually here, and you can see possibly, I hope anyway, that at some point, if we were to superimpose this onto this, that these graphs would meet, and the result would look something like this. So we're looking for that point there. Now, if you don't understand how I got the various points on these, especially these two graphs, I strongly suggest that you skip back a couple of videos and just look at how you graph linear equations. Okay, so what does substitution mean? Well, basically we have to assume that y is equal to y, and therefore this at some point is equal to this, although that may not always be the case, and we get into that in another video. But anyway, what we do is we take this and we substitute this for y. And so instead of y being here, we have 2x plus 5. And that equals, we make that equal negative x plus 7. And then we go to work rearranging. And we gather the x's on one side and the numbers on the other. So we wind up with 3x is equal to 7 minus 5, which is 2. And therefore x is 2 over 3. 2 divided by 3 leaves x on its own. What that's done is it's given us the y-coordinate of the point at which these two things intersect. Right, that's the first point. Now, the second thing is this. We take this number and we substitute it into one of these equations. I've used this one because it's got positive numbers in it, and I just prefer to deal with positive numbers. So, 2 times the x value, 2 over 3, plus 5, gives us 4 over 3, 2 times 2 over 3, plus 5. That is 1 and 1/3, that is 1 and 1/3, 1 and 1/3 plus 5, which gives us 6 and 1/3. So the coordinates of this point of intersection are 2 over 3 and 6 and 1/3. That's the x-coordinate, that's the y-coordinate. And that is very basic substitution. Now, let's move along. What's up next? Some more examples. Now, these are examples without the graphs involved. So we just go to work as previously. I'm actually a big fan of drawing the two graphs one on top of the other. I don't do it here just to save time, but I do it because it gives me an idea of what I'm looking for, and if what I work out is at serious odds with what I see on my graph, I know that potentially I've made a mistake somewhere. Anyway, let's get into this. So we're going to use substitution. We're going to substitute one of these expressions here for y. It's this one. We're going to substitute it for that y there. So 7x minus 8 we put there. And we make that equal to 3x plus 2, which you can see there. Gather the x's. Bring the 3x over here. It becomes positive. That gives us 10x. Take the 8 over there. The negative 8 becomes positive 8, and we get 10x equals 10. X, therefore, will equal 1. Substitute that value into one of these equations. And away we go. So let's do that. We're going to substitute 1 into this equation here. So y becomes equal to 7 times 1 minus 8, which is negative 1. So our coordinates, the coordinates at which these graphs, or rather the graphs of these equations intersect, are x equals 1, y equals negative 1. Okay, one more. Slightly more awkward. Again, it's going to be substitution, but as you can see, these equations are not written in such a way that is you could call convenient. Right, so what do? Well, we've got an expression here for y. Y is equal to x plus 3. So we could get rid of this y here simply by putting x plus 3 where it stands, and that's exactly what we do. So 2x minus 3, and instead of y, x plus 3, negative 3 times x plus 3 equals negative 8. Expand this, we get 2x minus 3x minus 9 equals negative 8. Do a little bit of tidying up. 2x minus 3x is negative x. Negative x equals 1. That is negative 8 plus 9. So if negative x equals 1, x is going to equal negative 1. We take that 1 and we pop it into, that negative 1, and we pop it into the easier of the two equations to work with. I'm telling you, if you can't spot it, that is the easy one to work with. Right. So y is equal to negative 1 plus 3. Y is equal to 2. Right.